So welcome back. In the last video we looked at how to deactivate an alert. And the way we did that is simply by finding the ID with, the alert with the alert ID that we were passing, that we were getting from clicking the button in the alert page, and then calling the deactivate method. We had to add another property to the alert called self.active, and the deactivate method only sets that to false and then saves the alert to the database. After setting the alert to be deactivated, we were redirecting to users.userAlerts, which is the list of alerts. In this video, we're going to make sure that we can activate them as well. So we're going to need to copy all of that and change it to activate, and then change that to activate alert. And instead of deactivate, change that to activate, and that's all the changes we need. And that is now going to reverse the deactivation and indeed activate the alert. Remember, the activate method sets self.active to true and then saves to MongoDB, so it does the opposite of deactivate. However, the activate method isn't in this page. This is a deactivated alert, but it's still showing as deactivate alert. So we need to make sure that if the alert is inactive, we are showing some green button that shows activate alert. If the alert is active, we want to show this red button. So let's go into the template for alert, not here, but this one, this template. So alerts.alert, and make sure that we are indeed changing the button depending on the state of the alert. So if alert.active, which means the alert is active, this essentially means it's true. So if alert.active, we want to show this deactivate alert button. And if not, then we want to show a different button. But I'm going to copy this button, paste it down here. And instead of btn danger, I'm going to call it btn success. Instead of alerts.deactivate alert, I'm going to change that to activate alert. And instead of deactivate alert there, I'm going to say activate alert. So we're going quite quickly now these days. And I'm going to refresh this, and notice how this is an inactive alert. We're going to activate it now, go back into it, and now it says deactivate. We're going to do that, go back into it, and now it says activate. Fantastic. So this is working, and notice that if we go to our alerts and click on this one, it's still going to show us deactivated, and when we click that, it's going to show us activate and all that. So that is because the default value for the active property is true. So even when the alert has never been activated or deactivated, it's still showing as active, which is what we wanted. Okay, so that's everything we wanted to do in this video. Now we are able to activate and deactivate alerts. So let's move on to the next one. Hi and welcome back. I think the next logical step is for us to be able to see in our alerts which ones are active and which ones are not active. So let's do that. Let's go into the users.alerts page that is going to show the list of alerts, and let's change things up depending on whether the alert is active or not. So what we want to do is we're going to say show a wee icon beside the alert if it's active, and show a different icon if it's not active. So this A here that has the link can actually also have classes. So the classes it's going to have are essentially warning, list group item warning. And when we do that, notice that they both suddenly get colored in yellow, and they also lose a bit of the styling. So if we copy this like that, list group item and list group item warning, and we refresh, now they are showing as yellow. So we want alerts that are inactive showing up like this. So how do we do that? Well, it's fairly simple. We say class is list group item, and we're going to say, and the class is also going to be list group item, sorry, misspelled that, item warning if alert active, if rather not alert active, else, and just 2 quotation marks there. So what we're saying here is the class is going to be list group item, and it's going to be list group item warning if the alert is not active, and if not, it's just going to add an empty class which is not going to do anything. Okay, so let's refresh that, and notice how now this one is showing as inactive, this one is showing as active. So this one is active. When we deactivate it, they both show as yellow. This one is inactive. When we activate it, it shows as white. Excellent. We can do something else though. We can also add a small glyph icon to the heading, and just to make sure that users know what that means. So inside this h4, I'm going to add a span. So I'm going to say span class is like that. Glyph icon remove circle, span like so. If not alert active, else like so. Okay, so let's have a look at what this is doing. We're going to add a span class, glyph icon remove circle, if the alert is not active, and if not, we're just going to add an empty string, which, as I said, isn't going to do anything. Let's have a look at that. Refresh, deactivate one, and now that shows as a small, delete circle sort of thing. Okay, so that's all we wanted to do for this video, and I know that we're going a bit faster now, but hopefully you can follow this without a problem. I'm sure you can do. We're just writing a string to this class if this property is true, and if not, we're just writing an empty string. And that's not going to do anything. Remember, the space is always going to be written down because it's not inside this alert active thing. So we could remove that or we could leave it in. In either case, it doesn't really affect the way the CSS is handled. So there we go. We've now added the ability to show inactive alerts in our list. So now let's move on into the next video. Hi and welcome back. In this video, I wanted to add some extra bit of functionality to our inactive alerts. When an alert is inactive, chances are the user may want to just delete it entirely. And if they do, that's going to save us some disk space, for example, in our database. So we want to allow users to permanently delete alerts. Let's see how we could do that. Let's go into the alert template here that is showing the buttons to deactivate alerts or activate alerts. And when an alert is inactive, i.e. when this button is showing, we want to show users another button showing you can delete this alert permanently. So a class is btn danger, and the href is going to be url_for alerts.delete alert, and the alert ID is going to be alert._id. And this doesn't exist yet, but we are going to add it momentarily. Permanently delete alert. So if we go to this page now, we'll get an error because alerts.delete alert doesn't exist. So let's go into the alert views and make that. So under the deactivate alert, I'm going to add a delete alert. And what this is going to do is very simple. Instead of calling deactivate, it's going to call a delete method. And that's it. We just renamed a couple of things, and now it's going to delete the alert, and then it's going to redirect to user alerts. So remember, that doesn't exist yet, so we have to go into the alert method and implement that. So we're going to say def delete, and this is going to delete this alert, and it's going to say database.remove, which doesn't exist yet either, alert constants.collection, where the _ID is self._ID. Okay, let's go into the database and add that in, that remove method, which is going to be a static method, def remove, and it takes in a collection and the query that we're going to remove, and what it does is database.database collection.remove query. Easy enough, innit? And that already exists inside the PyMongo client. So that's all we have to do. let's save that and go back into here. Deactivate an alert, go in here, click permanently delete alert, and now that has disappeared. So now our users can deactivate and then delete alerts. So for example, if they had many alerts, they might want to delete some to clean it up once they've bought the item, for example. So now they can do that. Fantastic. So that's everything for this video, and I'll see you in the next one. Hi and welcome back. During the recording, I realized a small bug that is very easy to forget, which is this price limit here. When we are creating an alert, the price limit has to be a number so that we can then compare an alert's price limit to the item's price. But here we are saving the price limit as a string, so we want to change that and say float. If not, when we refresh the price of an item, we might get an error. So that's that, and that's everything for this video. Just wanted to mention this small bug that nevertheless is easy to forget. I'll see you in the next video. Hi and welcome back. So our alert updater file is going to get all the alerts that need an update, and then it's going to load their prices and send an email. However, we've forgotten to add something here to this find needing update, which is that alerts have to be marked as active so they can be checked. Right now, both active and inactive alerts are being updated, and we don't want that because that's a waste of resources. Alerts that are marked as inactive should not be checked. So what we want to do is the last checked the last checked has to be less than the last updated limit, and the active has to be true. And now what that's going to do is inactive alerts are not going to be checked, active alerts are going to be checked. Okay, that's everything for this video, and I'll see you in the next one. Hi and welcome back. Now that we've got a lot of the functionality in place to create alerts, check them, and essentially do everything that the basic product should do, we need to give our users some more information. For example, what stores are supported and how they can, and essentially what stores they can get pricing alerts from. So let's create the store index. And where we're going to do that is in the store views. So let's go into stores and views, and notice that we've got the stores index here. So instead of returning this as a stores index, we're going to return a render template function, which we have to import. And that's going to be stores/store index.jinja2, and we need to create that as well. So let's go into our templates, into our stores, and show the new file and create a store index.jinja2 file. Yes. And notice how it's appended.html at the end, so I'm going to rename that, refactor and rename, and remove the .html. Okay, so store index.jinja2, and it tries to make it HTML file, but we don't want that. In fact, what we want is just this standard block here. So we're going to extend base.jinja2, and then the block content that we're going to show nothing here yet, but we're going to change that. Okay, however, before being able to show the store index, we actually need a list of stores. So how are we going to do that? Well, very simple. We're just going to say get all the stores from the database. So stores is going to be a list of all the stores. We're not going to do that in this video. We're just going to work on the store index template. This index template is going to have a div, which is going to be the page header. And we know all of this already. So let's do that. And then a h1, which is going to be stores. And then a small tag that is going to be the list of supported stores. Perfect. And then we can indent that slightly. And then we're going to have the list of stores. It's going to be just like the list of alerts. So I'm going to go ahead and create that. Div class is list group. And we've used that in the list of alerts in the user list. And then we're going to say for store in stores and down here end 4. And what we're going to show here is a list of stores. So I'm going to add a HTML comment, and this is just like a Python comment. It's something that doesn't get executed, but nevertheless will tell us what to do. And these HTML comments are like that. They need to start with a less than crocodile clip, an exclamation mark, and 2 dashes, and they need to end with 2 dashes and that greater than crocodile clip. And display list of stores here as, and the way we're going to display them is, as we know, a href is a pointer, a link to somewhere. The class is list group item, and that's it. And then inside that they've got a h4, which is the title, and it has a class list group item title. And I'm putting these in a comment because we don't really have any information yet. We don't have any stores. So when we try to do this, we're not going to get anything back. And finally, it's going to have a p, which is the list group item text, which is going to be the description of the store, if you will. Okay, so that's what we're going to display there. And finally, at the end, we're going to have a button to create a new store. So href is going to be URL for stores.createStore, and then we're going to have that closing, and we're going to have the span class glyph icon plus, like so, and create new. Okay, so when we go here, the create store doesn't yet exist, so we're going to get an error. So let's add that in. At store blueprint.root, like new methods are going to be get and post. And we know this, we've done this for the alerts, for example. And then there's going to be create store. And this is going to return, this is the store creation page for now, so that we can click on it and add something new. So let's do that. So let's go into our stores, and then we can click create new, and this takes us to this is the store creation page. So that's the header, and that's the button that we've just created. And notice that the loop in here is a comment, so it doesn't do anything for now. What we have to do in the next video is get a list of all the stores and display them there. So I'll see you in the next video. Hi and welcome back. So the way we're going to do this is we're going to say stores is store.all, and we're going to have to import the store model. And now we're going to need to create this all method, and the all method is just going to return all of the stores that are currently available in our system. So let's go into the store model, and at the very bottom type a class method that is going to be all, and it just takes a CLS and then returns a list of objects where each object is elem for elem in database.find for the store constants.collection, and finds everything. And in order to find everything, remember we need this opening and closing dictionary, essentially this empty dictionary. So that's everything. And then we can go back to the store index template, back to the store view, and say stores are stores. There we go. Now we're passing the stores variable to the template, and we can come back to the template and now delete this comment here. Okay, so let's go back. Let's delete that bit as well. Let's go back into here and do that, and now we get title and description there, but obviously nothing in them yet. So let's fix that up. What we want to do is for each of the stores display the kind of forgot to close that A there. That's a bit better. For each of the stores display the store name, for which we are going to need just to do store.name. And for the description, we're going to say all URLs in this store should start with, and then strong store.url prefix. And there we go. Now we've got some information for our users, and when they click on this, they're not going to do anything for now. because the href is actually just the hash symbol. So we need to change that and start showing something a bit more interesting. And we're going to show URL for stores.store page, where the store ID is going to be store._ID. And now when we refresh, we get an error because we don't have this view created yet. So let's go and do that. We've got the store page, and right now it's accepting the string name. We're going to change that and change it to store ID, and then we're going to get that and pass it like so. And now we can refresh, and now we can click on it, and it will get an error again, but at least this part is now working. So what to do here is, instead of pass and returning nothing, we're going to return this is the store page. And now we can refresh, press it, and takes us to this is the store page. So our entire program is coming together very nicely here, and we just now have to add the last couple of bits, which is creating a store, editing a store, showing the store page, and then editing alerts that are already existing, and that's pretty much us. So we are getting pretty close to the end here. So hopefully you're enjoying this design and development process happening all in one. And I know that we're going quite quickly, but I think we're just doing the same thing over and over with small minor changes and introducing new content periodically and slowly. So hopefully that's okay for you guys. And yeah, I'll see you in the next video where we're going to continue with this. Okay, so let's change the store page. So it is returning a render template function where the template is going to be stores/store.jinja2, and the store that we are getting details from is store.getById, where the ID is store ID. So I think that makes sense. We're rendering the template store/store.jinja2, which we've already created, and we're going to pass that template a variable called store, and that variable is going to contain the value of the object that we can get by ID, where the ID is the one that we got in the URL. Now that we're here, I'm also going to add a couple more routes for editing and deleting a store. So it's going to be edit and then string store ID, where methods are going to be get and post. That's going to be def edit store with store ID as a parameter, and it's just going to say if request.method is post, do nothing, else return edit store page, and we're going to import the request there. So we know what this is. We're adding a new endpoint called edit and then the store ID. It's taking in the store ID as a parameter, and it's going to be dealing with get and post. So get, this is going to end up rendering a form, and the post is going to be dealing with the form and changing the store details. And then we're going to create another one for delete string store ID, and the method is actually just going to be get. So we don't need to add anything. Def delete store underscore ID. Sorry, we don't need that. There we go, and return delete store, which isn't doing anything just now, but it will do soon. Okay, so what we wanted to do in this video, apart from adding those views, is dealing with the store page. So let's go and do that in here. So let's open up stores.store.jinja2. Notice how it has nothing here yet, but it is going to have things momentarily. What we're going to add is the page header. And that's going to have h1 store, and then small is going to be store.name. Notice that we've got the store variable in there. And then we're going to have another, a P that is going to say all URLs in this store should start with strong store.url prefix. And we know this, we've done this just in the previous video. And then we're going to have the panel, as we know from the alert, panel default, and then it's going to have a div class panel body. And what that's going to do is it's going to give us an area where we can add some content to the panel, And what it's going to have is two anchors. One for editing the store, A class BDMB and warning. href is going to be URL for stores.editStore, where the store ID is going to be store._ID. The role is a button, and what it's showing is edit store. Okay, and then I'm just going to copy that and paste it so I don't bore you too much. The class for this other button is going to be btn danger, which is the red one. Instead of edit store, we're going to show delete store, and instead of role D, we're going to change that to role. And instead of edit store, it's going to say delete. Sorry, permanently delete store. Okay, so let's go into here and notice how now we've got these buttons: the header, the small description of the store, edit store, and permanently delete store. So when we press these, we're just going to get edit store page or store ID. Sorry, well, let's go back to the store views, and delete store. Forgot to add the store ID there. Okay, and that's delete store page. So there we go. And now we can continue in the next video and actually make sure that we can edit and delete these stores. So I'll see you there. Hi and welcome back. Before continuing, we should probably be able to add and create new stores. So let's do that in this video, and then we can move into editing and deleting them. Remember that editing a store is going to be extremely similar to adding a new store. In fact, the edit store endpoint that we've got here is something we can reuse here in the create store. The create store can accept requests using get or post. Remember, post meaning it's getting sent some data, and get that it is the user is wanting to retrieve something from the page. So if the method is post, then we want to deal with the request and add a new store. If the method is not post, then we are going to skip this section and go straight to this return statement. And here we're going to be returning edit store page, but in fact we want to return a render template of the stores/new store.ginger2. Okay, and in the post we're going to be dealing with the request. But first, let's make the new store page. So I'm going to go into my stores and open up the new store.ginger2 file. And here we're going to put the form that is going to allow us to create new stores. First, let's create the page header, which is going to be the title. And here we're just going to put create store. And then in another div with class form size, we are going to put the form with method post. And remember that if we don't specify the action of the form, then the action is by default the current page. So this form is going to be sending data to the same page that the form lives in, which is what we want, because this page is accepting both get requests and post requests. And remember, the form is now going to be sending a post request. Okay, and then we're going to have a div with a class form group. And here we're going to have our label that is for the name of the store name. And then we're going to have an input of type text and class form control. We've done this so many times now that we already know how to do this. And there's one comma there that shouldn't be there. And the placeholder is going to be name, or maybe store name. Okay, this is our first form group. And then I'm going to copy that, paste it down here, and we're going to say store URL prefix. And instead of name here, it's going to be URL underscore prefix. And so in there, the placeholder is going to be http:// ... And we're going to include the area described by, and this is going to be store URL prefix help. And that is going to be a span down here with ID store URL prefix help and a class of help block. And then the span is going to contain what characters do URLs of all items in this online store start with. Okay, so let's try and go over to this store and go into stores and create a new store. So here we've got this page, store name, store URL prefix, and our small help block. Okay, the next thing we need is the tag name that the store is going to use to search for information in the content. So I'm going to copy this form group, paste it down here, store tag name. I'm just going to remove store from there. Tag name, and we just once again replace these things here, and the placeholder is going to be span. And actually the most common tag name for these online stores is span, so I'm going to add a value span in there as well. And finally, the area described by is going to be tag URL, store tag name help. And then I'm going to paste that in there. And the tag name is what is the HTML tag of the item that contains the item price, usually span. There we go. So let's refresh that. And there we go. Maybe we can add something like this. That makes it look a bit better. So we can do that. And finally, the last one is the query. So I'm going to copy this, paste it in here, and this is going to be search query. And it's just going to be query in here. The placeholder is going to be something along the lines of ID is price now, for example. Notice that I've done a small change, and it's that I've used single quotation marks around the sides and double quotation marks on the inside of this placeholder. Similarly, we are going to have to do that when we are writing stuff in this field. So I'm going to copy that and paste it in there. And the reason why we have to do double quotation marks on the inside is because JSON, the JSON specification, only accepts double quotation marks as being valid. It does not accept single quotation marks. So our users are going to have to use double quotation marks in this field so that we can then parse the JSON and put it into our database. And we'll find out what happens if we don't do that. And the area described by is going to be query help block. We're going to copy that, paste it down there, and this here is going to be what JSON query would we have to do to find the specific tag with the price. Remember to use double quotation marks. Okay, so let's refresh, and there we go. Notice how the help field actually wraps around nicely. And the last thing we need is, of course, the button of type submit. And the class is going to be btn success. Sorry, let's use default because it's all the gray. And that's going to be create. And there we have it. So this is how we could create a store. And that's how we're going to be creating stores from now on when we use this app. So now we have to deal with the post request that is going to be coming with this data into the endpoint here. So now we're rendering the form. We need to now be able to deal with the data. So let's do that. If request method is post, then we'll get the stuff from the form. So name is the store name, request.form/name. So not slash, but square brackets. URL prefix is request.form URL prefix, and tag name is request.form tag name, and finally query is json.loads request.form/query. There we go. And we need to import JSON. And why do we do this? Well, request.form query is going to be a string, and we want to convert that string into JSON. And that is because Beautiful Soup expects a Python dictionary to be to be what we're giving it in order to do the search. So JSON.loads takes this string that is a JSON representation and converts it to a Python dictionary. Finally, what we want to do is store name, URL prefix, tag name, query, dot save to Mongo. And now we can save this store here. Okay, so let's save one, right? Test, http test.com, and let's click create. And now if we go back to the stores, we can see that this test is in there. But as you can see, we stayed in the create new page. So at the end, what we want to do is return a redirect to the URL 4 of the users.stores. Sorry, not users.stores, but the store index. So that would be index there. And we'll need to import redirect and URL 4. So now when we go to create new, we can say test2 http www.test.com and then click create, and we move back over here. Let's see what happens when we use single quotation marks in the search query, like I mentioned before. Let's say instead of that, we use single quotation marks. It doesn't like that. A JSON decode error. Expecting property name enclosed in double quotes, and we used single quotes, so it gave us an error. The property names, in fact everything in JSON, has to be enclosed in double quotes. So here, if we were to use double quotes, that would all work fine. Okay, and these stores are then added to the database, so everything is working now. And now the next thing to do is indeed to be able to edit these stores and to delete them. So I'll see you in the next video. Hi and welcome back. So in this video we're going to be adding the ability to edit and delete stores. And this is going to be very simple because we're just going to be doing things that we've done before. In order to edit a store, what we need to be able to get is the different details of the store and change them. So what to do is just copy the create store form. So I'm going to go into the Ginger2 template and essentially copy everything and paste that in the edit store page. And then rename this to edit store. And now something we have to realize is that this store page, this edit store page, is going to be editing a particular store. And that particular store is going to be passed in as the store variable. So therefore, each one of these input fields can already be pre-populated with the stored data. So at the end of this input text that contains the store name, I can add value equals store.name. And now when a user goes and edits this, they're already going to see the current store name in the field, and they're going to be able to change it, and that's then going to change the store name. And I know we haven't done the back end of this just now, but we're going to do it in a moment. And I'm going to do this for the other fields as well. Value is going to be store.url prefix. The value here instead of span is going to be store.tagname. And finally, the placeholder here for the query is going to be store.query, and we're going to convert this store.query to JSON, which is essentially what we want to write here. So what we do is say store.query, and then we use a pipe, and that means apply this to JSON to the query. And what to JSON is, it's called a filter, and essentially it applies a transformation to store.query. So what this does is essentially converts store.query to JSON format. Okay, and once we've done that, we are ready to, well, we first have to change this and change it to, for example, warning, change this button to update, and now we can go and change the back end as well, the view of this edit store. So the edit store page is going to be a render template, where the template is stores/edit store, and the store variable is going to be store.getById store ID. The store ID, remember, is being passed in as a parameter. Now, when the request is of type post, it means the user has pressed update in that form. And what we can do is get the form details and update the store. So what to do is come here and say name equals request.form name, and all that stuff. I'm just going to copy it from down here. And then say the store that we're editing is store.getById, store ID. And then store.name equals name, store.url prefix equals URL prefix, store.tag name equals tag name, store.query equals query. And then store.save to Mongo. Fantastic. So that's us. And finally, return a redirect to URL4 of the index. And what that'll do is let us modify a store, and then it will redirect us back to the index, which, as you know, is showing us the list of stores. There's a small thing that we can improve in here, which is that store.getById is being called twice. So let's change that. Let's move this first line over outside of the if statement. And then down here, just say store. There we go. That way we can use the same store both in the if, and also if we're not executing this if, because the method is not post, we can still use that store down here as well. Okay, so let's go here into our stores, open up one and press edit, and notice how now this form has all those details in here, and we can potentially change one of them, but I'm not going to change that one because that one actually works. So I'm going to change this one into test2 without a space and press update. And now we get a duplicate key error. So we've fixed this before, and we can certainly fix it again. The problem here is that when we press save to Mongo in the store, here, that is inserting into the database something. And because this store is already in the database, we're getting a duplicate key error. It's trying to save something with the same key, the same underscore ID again, and it can't do that. So what we need to do, as we know, is to use the update method. So we'll change that to update. And the query is going to be underscore ID is self._ID. There we go. So now let's try that again. Let's update, and now notice how that changed to test2. Okay, pressing the permanently delete button doesn't yet do anything, but we're going to do that just now in this video as well, because it won't take very long. What this delete store endpoint has to do is say store.getById store ID .delete. And we've done this before, we know how this goes. Let's go into the store and create the delete method, def delete, and say database.remove store constants.collection, where the underscore ID is self._ID. That's it. Let's go back into the view, and instead of returning delete store, let's return a redirect to the URL4 of the index, which is the store index. Okay, let's try that again, and now that gets deleted. Fantastic. We're going quickly, and I think everything is suddenly picking up a lot of speed, but for me at least, it makes a lot of sense the way that these views and these models and these controllers and the templates are all working together. But of course, if it is not clear, or you've got any questions, then please, by all means, do ask away in the course discussions. And that's it. So this is everything we wanted to do about editing, deleting, and adding stores. And now what we have to do is continue with the app and move on. So I'll see you in the next video. Hi and welcome back. Now the next piece of functionality that we should add is the ability to edit alerts. We've got the ability to add alerts and to view an alert page, but we cannot right now edit an existing alert. And I think this is interesting just in case a user wants to change the price point at which they are getting emailed. So let's go in here and add another A of class btn-warning, and href is going to be URL underscore 4, and then alerts edit alert, for example. Okay, so it's also going to need an alert ID, which is going to be alert._id. The role is going to be button, and the text is going to say edit alert. So this is not going to work because the edit alert endpoint doesn't exist yet. So let's go and make that. Let's go into the alert views and create the edit alert. And I'm going to make it just here below the create alert. Root, and this is going to be /edit /string alert ID, and it has 1 colon too many. And the methods once again are going to be get and post. The get is going to be to render the edit form. The post is going to be to actually deal with the post, deal with the request. It's going to require a login. And finally, it's going to be called edit alert. And it's going to take an alert ID. Okay, all it's going to do is if the request method is post, then it's going to deal with the changing of the alert in the back end. And if not, we're going to return render template, where the template we're rendering is the alerts/edit alert. We still need to make that one. And of course, when we're editing this alert, we're going to need to pass it the alert.findById with alert ID. However, when the method is post, we are already going to be getting some data back. First of all, let's make the form, and then we'll figure out what exactly we're getting back, and we'll deal with that. So let's go into our alerts template and create a new file called edit alert.ginger2, and then go into the new alert and copy that. And we've done this before with the stores. Sorry, I'll just copy everything, in fact, and rename the header to say edit alert up here, and then all these things can just stay there. However, let's think about what sort of things we want to allow the user to update. Do we want them to update the alert name, i.e. the item that the alert is for? I would be tempted to say no. I would be tempted to say this alert is for this item, and if you want to change the alert so it's for a different item, then you should create a new alert entirely. You can delete this one and create a new one. And similarly for the URL is related to the item and not specifically to the alert. So I would say if you want to change the URL, i.e. which item you are checking for, I would suggest delete the alert and create a new one. So I'm going to be deleting these and thus not giving the user the ability to change the alert name or the alert URL. However, actually, let's undo that. And instead of just deleting them and the user being left wondering what's going on, let's add the disabled tag here. And what that is going to do is it's just going to make them grayed out. And the user is going to be able to tell that they won't work. In some cases, you may have to add the class disabled there. But with the more recent browsers, that should work. Okay. Finally, in here, the placeholder is going to be 45.0, but we need to add the value, which is going to be the value of the currently being edited alert. So that's going to be alert dot price limit, is it? Price limit. There we go. And instead of create here, we're going to say update, and instead of btn default, I don't know, we can leave it as btn default just so it's a bit gray there. Okay, so let's go and check the alerts. So I'm going to have to sign in. Oh, password is wrong. I can't remember if it's 123 or 1234. So this is the alert, and now we can edit the alert, and we get these grayed out icons, and we can change the alert limit. But obviously when we do that, nothing really happens because our view isn't yet dealing with the post request. So let's do that just now. The price limit that we're getting from the form is a float request.form price limit. Remember, we have to convert it to a float so it stays valid. The alert is alert.findById for alert ID. And now we're setting the price limit to be the price limit, and then we're saving to Mongo. Finally, at the very end of it, we are going to return a redirect to URL4 for the index in this, sorry, not the index, the users dot alerts, isn't it? I can never remember what it is called. Let's go into the user views and say user alerts. Okay, there we go. So alert views, users.user alerts. So now when we edit the alert, we're going to get redirected back to the user's alerts. Once again, we've got this where we're calling alert equals alert.findById twice. So we can cut that, move it out of the if statement, and then put it in here. Remember that if the requests method is post, we are going to change the price limit as per the value we get in the form. But if it's not post, this is not going to run at all. And then we're going to just be using this alert down there. So that saves some code. So let's save that. Come down here. Let's change that to 45. It's now 45. And when we go and edit it again, the alert limit is now 45. So I should be getting an email at some point. Okay, and that's how we can edit these alerts. Now, to delete an alert, we've already got that, so we don't really have to worry about it. We can deactivate, we can activate, we can get alert pages, and we can check the price. So the alert is now finished. We can edit, create, delete, and everything, and similarly with the stores, and similarly with the users. So we're approaching very quickly the end of this app. I'll see you in the next video. Hi and welcome back. In this video, we're going to make sure that some of the options are only available to admins. So we're going to learn about this frozen set that we don't know what it is yet. And we're also going to be looking at how to use this config file in the Jinja template. So the frozen set is essentially a Python built-in data structure. A set without the frozen part is a data structure which contains a number of elements, and it doesn't contain duplicates. So for example, a normal list can contain duplicates. We could have this element here multiple times. And that's fine in a list. When we try to convert the list to a set, what it does is it removes the duplicates. So only each element will only appear once. And in a set, we can add more elements. So we can say, we can join the set with another set, for example, and get a final set that contains the elements of both. So we could do that with a set. In a frozen set, which is a special type of set, it is frozen, which means we cannot add or indeed remove any elements from the set. So admins is going to be a config value that is going to be this frozen set. So the administrators of the application are not going to be able to change while the application is running. Although you can always change this file and that will change your administrators when the program restarts, of course. So what we're going to do here is fill that in with your admin email. So in my case, that's going to be my email. That's the user that I'm using in the application. And now in the Jinja variable, we can use the config property to access the admins that have been written in this config file. So for example, let's say that I want only administrators to be able to add stores. I think that's a fair requirement. So what I'm going to do is I'm going to say if the session's email is in that frozen set, and the way we do that in Python is just with the keyword in. So if session email is in config.admins, then we're going to show this button, and if not, then we are just not going to show it, and it's not going to appear on the site. However, remember, this only applies to this button. So if users are, if they know the address of the Create Store page, they're still going to be able to access that page. So that's something to keep into account. This is only going to make it a bit nicer for those users that are just using the application without intent of messing it up. So that's only going to show the button to those users that are admin, so in this case, my user. And I'm going to do that there, and also in the store.ginger2 template, we're going to make sure that only admins can edit and delete stores. So what we're going to do is here put that if statement as well. Like so. So now only administrators are going to see the buttons to edit and delete stores. Okay. So what I'm going to do next is make sure that only admins can visit these endpoints. Remember, right now we've made sure that only admins can see the buttons, but users that know the address can still visit the endpoints. So what we're going to do in the next video is make sure that only administrators can view the endpoints. So I'll see you in the next video. Hi and welcome back. In this video we're going to make sure that not only can admins only see the buttons, but also that the users that have the address of the Create Store page, for example, cannot visit the page without being an administrator. So the way we're going to do that is we're going to go into the store views, and we're going to make sure that these endpoints are only accessible to administrators. So the endpoints that we want to only be accessible to administrators are Create Store, Delete Store, Edit Store, and that's it. The others should be accessible for everyone else. So in order to do this, we're going to refer back to our user views, remembering this user decorators requires login. This requires login decorator. Make sure that the user is logged in, that there is an email in the session keys, and that the key email inside the session is not none. If it is none, then it redirects the user to the login page. Now we're going to make another decorator that is going to verify that users are logged in. So instead of requires login, it's going to be requires admin permissions. And instead of checking the email is in the session keys, well, it's going to do that, but it's also going to verify that that email is an admin. So what it's going to do is check that this is logged in. So email must be in the session keys, and email must be set to be something. And if it isn't, it's going to redirect to the login user. And, sorry, those brackets aren't actually required. And not only that, it's going to say if session email not in app.config.admins, and we're going to need to import app. So I'm going to go up here and say from app import app. And that's going to be, of course, src.app. If session email is not in the admins property of the config, then we are going to return a redirect to the login user, but without the next path. And indeed, we could send here a message to the user. For example, message is you need to be an admin to access that. However, we haven't got a way to display these messages on the site, so sending a message is not really necessary because, as I said, we don't have a way to display them. But if we did have a way to display them, then we could show the user different messages depending on which one is here. If the email is not set and the session is none, then we would say you need to be logged in. If the session's email is not in the admins config, we would say you need to be an admin. And we need to check for both because if we only check this one and email is not existing in the current session, we'll actually get an error saying the email doesn't exist in the session variable. So we need to make sure we're checking this as well as this. Okay, so now we can get this. I'll copy that and go into our store views and import the user decorators. So I'm going to say import src.models.users.decorators as user decorators. And then the edit store is going to have user decorators don't require admin permissions. There we go. And then we're going to make sure that is there as well, and there. So now, even if someone that is not an admin accesses the page, they won't be able to go in. They'll actually get redirected to the login page. Okay, so in the next video, let's verify that everything is working, and we're pretty much at the end of this section. I'll see you in the next video. Hi and welcome back. In this video, we're just going to be changing the Mailgun API call to make sure that we're sending in the link to the alert. So we're about to finish with this project. So this is one of the last few things remaining. Let's go into the alert model. And then notice how in the send method, there is this post request that sends something to the Mailgun API, which is then going to send the email from our alert constants.from to the user's email, and then the subject is going to be price limit reached for something, and then the text right now is we found a deal, link here. So we want to change this, so instead of link here, it shows a link to the item. So the way we do that is, as you know, with .format, and what goes in there is self.item.url. And now, when the user clicks that, they go straight to the link that they've put in the alert. And that's how we can make the users able to navigate straight to the item by clicking a link on their email. What would also be nice is to add an alert link, so a link to the alert page. And we could do that using the alert ID. So to navigate to the alert, visit there. And I'm just going to tab that in or press enter there so it's a bit easier. Sorry about that. There we go. And the alert page, as we know, would be URL_4 and all that stuff. However, because this is going to be running from the alert updater file, which is here, and not from our app, the alert updater actually doesn't know the endpoints and doesn't know the methods that are associated with them, so we cannot use URL4 in here because it's not going to be running through the Flask application. It's going to be running through a separate application, essentially. So what we do here is we have to hard code the address. So what I'm going to do is say the address is, and then here would be http://pricing.jslwtr.com. This is going to be the URL of the service once it's deployed, which we'll do in the next section. And then we have to here put the endpoint of the alert page. So let's go into the alert views and have a look at the get alert page. It's just alerts/ and the alert ID. Notice how it's alerts because the blueprint is prefixed with alerts. So this would be alerts/ and then .format self._ID. So notice how this one format and then another format inside it, and that's totally fine. You can absolutely do that. Notice how pricing.jslwtr.com isn't anything just yet, but it will be once we have deployed the application to a server. That we'll be doing in the next section, as I've mentioned. Optionally, we could put this in a config file, and that would maybe be slightly better. You can go and do that yourselves and just do another format with the config properties there, or you can just leave it like that for now. Okay, so this is how we include the link, and then in the next video, we're just going to be going over the last couple of things and finalizing the application. So I'll see you there. In this video, we're just going to be looking at our application, finalizing minor things that we've got to fix, and essentially just testing it all and making sure that everything is working so that when our users get to use it, they don't encounter any problems. So here I'm going to log out and have a look at the website first without logging in. This redirects me to the homepage, which is where I'm at. The stores let me see the different stores, and I can indeed click on one of them and go and look at the specific properties of that store, which doesn't show much, but still is working. However, notice there is a small line there at the bottom. And I don't know if you remember this from one of the previous videos, but this is actually a panel that has no content inside it, and it looks very thin, so much so that it looks like a line. So we're going to change this. We're just going to go into PyCharm and make sure that the panel isn't showing. So this is the single store page. And notice how we've got this panel here, and in the inside of the panel we've got to show the extra options for editing and deleting the store if the email is in the admin's config. So right now the panel is showing, but the inside is not because I'm logged out, so my email isn't in the admins. So what we're going to do is simply cut that and put it down here. Cut that and put it down here. And now the entire panel is enclosed in this if, so it shouldn't show when we access the page. Now I'm going to select everything with Control A or Command A if you're on Mac, and then press Alt Command L to re-indent everything. And you can find those options in code, and it is this one here, reformat code. So just in case the shortcut isn't quite working, you can just have a look at it there. Okay, and now we can go back to Safari and refresh, and notice how now that line is gone because I'm not logged in. We'll verify in a moment if that does appear when I am logged in. We've also got another link, which is the alerts, that really doesn't do much. And we don't really have a use case for the alerts, simply because each user has their own alerts. We no longer need this link here for anything. So we're just going to remove that. Let's go into the base template and remove the alerts.index link there from the navigation bar. We'll also go into the alert views and remove the topmost view, which is the alerts endpoint, the alerts index. That doesn't do anything. So we're going to remove that and then refresh. And notice how now that's gone. Okay, now let's log in. And notice how that seems to work. We've got the alerts here, and I'm going to press one of them. And we've got the price and the last check date. I'm going to check the price, see if that all works, and notice how that does update. So that seems to be working. We can edit the alert, change the price point, and that shows as 45. We can also deactivate the alert, and now that shows as yellow. We can reactivate it, or indeed permanently delete it. And we can also visit the site, but let's not do that in this video. We can create a new alert, and we know how to do that. And now that we're an administrator, we should see this create new button, which we do, and indeed the extra options here in the store as well. So we can edit this store, and we get an attribute error, which is related to the decorator that we wrote not long ago. Essentially, the file that has the error is this one here, which is line 23 in the decorated function that we created. So let's go into the models users decorators.py, find line 23, and see if we can fix this error. So we're going to users decorators, find line 23, and it's this one here. So if we immediately notice a problem, then we can just fix it straight away, and that's totally fine. And I know the problem is here, but if we didn't know what the problem was, because all this seems correct, at least if you don't spot the problem straight away, then we can just set a breakpoint there and stop the application and rerun it in debug mode. And what this does is now we can refresh the page, and when it gets to this line, the application is going to stop and it's going to let us essentially investigate a bit more. So let's do that. Let's go in here and refresh the page, and notice how now it goes straight back into PyCharm, and the program is stopped at this point. So I'm going to just open this up a bit more so you guys can see this a bit better. Notice how we've got this decorator up here, and it tells us what the func parameter is. It's the edit store function, and indeed it should be, because this is the page that we are accessing, the edit store page, stores edit. I'm sure you can't see that very well, but nevertheless, that's the page we're accessing. So we've got the edit store function coming in through, and then we're wrapping around that function with this other function. So essentially we're saying run this code and then run the original function, which is edit store. So this is going to return that template as we talked about. And now what it's trying to do is check the email that it's set, and that seems to work. And the next thing is it's trying to check that the session email is not inside this app.config.admins element. So let's have a look. Let's essentially select all of that, select session up to admins, and press the calculator icon, and this is going to let us execute that statement. So let's evaluate that, and it will give us this attribute error that we saw earlier. So we know that session email is working, and that's the email that's in the session, as you would expect. So what must not be working is app.config.admins. And indeed, it says that the config object, which is app.config, has no attribute admins. So remember, when you access something using the full stop, the period, then admins becomes, well, it's treated as an attribute of config. So what this is saying is this app.config has no attribute or property called admins. Oh, sorry about that. So let's delete the admins and see if that works. And now we've got app.config, and what this window gives us is the result of app.config. So what is inside app.config? And we can see that the admins key is indeed there. So what does this mean? Well, let's first look at the the app by itself. And notice how it's got a number of properties or attributes. And notice how they are, for example, these blueprints here, not enclosed in single quotation marks. They are just the words. This means they are normal attributes. However, app.config, its properties are enclosed in single quotation marks. This means they are not attributes, they are keys. And therefore, app.config is indeed a dictionary. So we need to access the properties using the dictionary way, which is to enclose them in square brackets and in the quotes as we see there. And now when we do that, we actually do get the frozen set, which is what we want. So let's change app.config.admins to app.config and accessing the key admins there. Now we can remove the breakpoint, stop the program, and rerun it as normal. And now we should be able to go back here and refresh the page, and indeed we see what we expected. So that's how you would use the debugger to try and investigate around a problem until you can find the issue. And that's an extremely important skill to have. But apart from that, we are done, essentially. Everything works, we've got the application here, and now what's left is to stop running it in 127.0.0.1, which is the local address, and start allowing our users to use this application as well, which we're going to do in the next section by deploying it to a server in a service called DigitalOcean. So I'll see you in the next section. Hi and welcome back. The first thing we have to do in order to be able to use Git is to register for a service that uses Git and that can host our code. So there are many services that can do what we want it to do, and one of them is GitHub. Now, GitHub and Git, although they are called very similar, they are as similar as JavaScript and Java, only on the name. Git is a protocol that we use to make these changes, essentially, and we can then push the changes to GitHub, and GitHub will host them. So Git is the thing that controls how the changes are handled. GitHub is the service that hosts the changes, lets us share them with other people. But they are not the same thing. They are made by different companies. GitHub is a for-profit organization. Git is a free software. Aside from GitHub, there are other tools or services we can use, such as Bitbucket or GitLab. You can view them if you want, and I don't really recommend one over any other, but GitHub is the most popular one. So once you're at the GitHub page, it's just github.com. You'll have to register. So I'm already registered, but I will sign out just for you guys to have a look at what this looks like. Simply picking the sign up button or picking your username, your email, and a password, and then clicking sign up, and then you'll be inside GitHub, and we can continue with the course and forking the project, which is going to be the next video. I'll see you there. Hi and welcome back. Once you've signed up, you can come to github.com/orgs/schoolofcode-me, and that will take you, github.com/schoolofcode-me, and that will take you to the organization page. So these are the repositories that I've made available for you to have a look at and download, and these include all of the apps that we've built in the course. The latest app that we've built is Price of Chair. So we can go into that, and there you can have a look at the code that I've created and that we've gone over the last couple of sections. And then there's also a bit of a description about the application as well. In order to get started with deploying this to your own server, the first step is going to be to fork the project. So pressing on fork, that will make sure that you can copy the entire repository. So what that'll do as soon as you press fork is that it will make a copy of the entire repository, but say that you are the owner of that repository. So you can do that, just press fork, and then instead of schoolofcode-me/priceofchair, you'll see your username/priceofchair. So I'm going to do that just now because this is not actually my username. And then where should we fork this repository? It asks me because I've got two accounts essentially. And I'll click on my personal account. And notice how now it says jslvcr/priceofchair forked from the original repo, which is that one. And now we can make changes to this repository. You can make changes to the repository that you forked, and that won't affect the original repo. So don't worry about making changes that will break things or anything like that. Something to remember, however, is that if you do make changes and you do upload those changes to GitHub, they will be publicly viewable. So other people will be able to see those changes, potentially copy them, or if you put passwords and things like that inside your code, people will be able to see those passwords if you put them inside your code. So something to remember, don't put your passwords inside your code. Okay, so once we've understood this, remember to not put any passwords or API keys or anything important and sensitive in your code. Once you've understood that, you can continue, and now we'll work on downloading or cloning this repository. So I'll see you in the next video. Hi and welcome back. In this video we're going to be installing Git for Windows. In order to install Git, the easiest thing to do in Windows is to download the GitHub desktop application. Now in this course we're going to be using the console, we're not going to be using this graphical interface, but it nevertheless installs Git for you, and therefore it is the easiest way to do it. The only thing you have to do is to go to desktop.github.com and then download GitHub Desktop for Windows 7 or later. In my case I'm using Windows 10, but you can use Windows 7 or later. Once you press that, it will download, and then you only have to open the application and install it like any normal program. And then it will download and it will install it for you. So I'm just going to pause real quick while this completes, and then we'll continue the installation. Once it is downloaded, it will prompt you to install, so we can just press run, and that will start the installer. And then you will receive a window like this one, where it'll ask you to log in with your GitHub username or email and your password. So let's do just this. Remember, using the username that you registered with previously, and I'm just going to put mine in. And it seems like I forgot the password, so I'm just going to check that real quick, and I'll be right back. Okay, so that's that. Remember to put your email in and your password. I was trying to use my username, but that didn't quite work as I intended. So use your email to log in and the password. And then it asks you to configure Git. So whenever you make a commit or you send some code to Git, then it's going to use these details to identify you. So it's going to put your name, potentially your email, in every commit so that other people that you're collaborating with know who you are and who is doing those changes. You can put here what you want, but I would recommend just using your name and your email. Then it can find local repositories. This is what you've got that are Git repositories in your computer. If this is the first time you're using Git, you'll most likely not have any, but if not, you may have some, and you may want to add them here if you want them to show up in the GitHub client. But if you don't want them to show up there, then you can just untick the boxes. And that's it. Now you've got GitHub for Windows installed, and we can use this in the console as well. So let's do that in the next video. Once you've installed GitHub for Windows, you will have two icons in your desktop. This one opens up the graphical client that we just closed, and this one opens up the Git shell, which is a command line version of Git that also acts as a extensible shell. So normally the shell we would use in Windows is the normal Windows console that we can get by just typing cmd here, command prompt. This is the default Windows console, and the Windows console is not very friendly with Mac and Linux. It does some things, especially when using Git, that aren't really recommendable. For example, Windows uses different line endings than Mac and Linux, so sometimes the Mac and Linux systems don't know where the line ends when the file was written in Windows. So let's not use this command prompt, and let's use the PowerShell, which is what Git for Windows, GitHub for Windows installs for you. So here we can run some commands, and we can run the Git commands. So if we just type Git, we get a list of the commands that Git makes available for us. And we're going to be working through some of these in the next few videos, both here in Windows. These will work both here in Windows and also in Mac or Linux. And we're going to be working on the Mac system, but they will work fine if you're using Windows. Just do exactly the same thing. And what we're going to be doing over the next few videos is downloading or cloning the repository, and also making some changes, committing those changes, pushing them to the remote repository, which is the GitHub repository, and then kind of working through that and understanding what's going on every stage. So I'll see you in the next video. Installing Git on the Mac is fairly simple, and in fact, if your Mac is fairly new, if it's Mavericks, which is version 10.9 or older, you don't even have to install Git. You'll most likely already have a version installed. If you're using macOS 10.9 or later, simply typing Git in your terminal will actually prompt you to install it, so you don't have to do any of these steps. However, I would still recommend following these steps so that you can get the latest version of Git. Later versions don't make many improvements, but sometimes make small performance enhancements or bug fixes. So it's always good to have the latest version of Git. The only thing we have to do is go to git-scm.com/download/Mac. And once we go there, it'll tell us that our download is starting, or we can just click there to download manually if we want to go a bit faster. And simply pressing that will download Git to your Mac through this SourceForge link, and here it is starting, and then we only have to install it like any other normal Mac application. So it is now downloading, and in a few minutes it'll be finished, so let's go through that together. Now it's finished downloading, we're just going to open it up here, and it shows us opening. And then once it's ready, you just have to double click that, and it will either install a new version or update Git to the latest version, which is this one that we've downloaded. And as you can see, it doesn't take very long, and then we are done here. So that's us downloaded. The only thing we have to do now to verify that this was installed is to open up Spotlight, that you can do with Command and Spacebar, and type terminal, and then you get a nice wee terminal here, and you can type git -- version, and then it should tell you, well, it does tell me 2.6.4, which is the version of the installer. If you're watching this at a later date, this version may be newer. And really that's everything you need to do in order to install Git on Mac. So that's fairly simple. Next, let's have a look at installing it under Linux. Installing Git on Linux is actually very simple. You can do so via a binary installer like we've done for the Mac, which downloads an archive and then you can install it by double-clicking on it, or you can more easily install it by using the package manager. If you're on Fedora or CentOS, you can use yum to install Git, and the way you would do that is you would simply type sudo yum install git-all. If you're on a Debian-based distro like Ubuntu, you can type sudo apt-get install git-all, and that will install Git on your system. So depending on which system you're doing, you only need to do one of these. Or if you are using a different distribution that doesn't have a package manager or doesn't use yum or apt-get, you may want to check out the link at git-scm.com/download/Linux. And I'm sure that will be fairly self-explanatory how to do that as well. So once you've done that, we are ready to get started with using Git. I'll see you in the next video. Hi and welcome back. In this video we're going to be cloning the repository. Remember to clone the one that you forked and not the original repo, so that you can then make changes to it. In order to fork a repository, this is actually very simple. The only thing we have to do is change this to HTTPS, copy all that, and then go over to your terminal or your PowerShell if you're in Windows, and then simply type git clone and then paste that in. What this will do is it's going to create a folder called price of chair, and it's going to put all the code inside that folder. So as soon as we press enter, it tells us what's happening. It says cloning into price of chair, and then it counts the objects that it's going to download, compresses them, and then it starts downloading them, and finally when it's done, it just tells us that it's been downloaded. Okay, so now a quick crash course on the Unix terminal. If you're using the PowerShell that we installed in the Windows section, then you can use these commands as well. If you're using the Windows console, then you may not be able to use these commands, but you will still be able to do git commands though. One of the first commands is called ls, and this lists the structure of a folder. So for example, if I type ls and then the price of chair, which by the way I am auto-completing using the tab key, so I'm just typing PR and then pressing tab, and then that tells me there's multiple things with PR, which are 2. If I type PRI and then I press tab, it auto-completes to price of chair because it knows this is the only element with that name. So when we do ls price of chair, it tells us the structure that is inside price of chair. So essentially what files and folders are in there. And as you can see, we've got 2 folders, readme files and src, and 2 files, readme and requirements.txt. Now, the current directory, which directory you're in, i.e. which folder you're in inside your computer, can be seen using another program called pwd. And this gives you the present working directory, i.e. where you are right now. And this gives you the folder in which you're in. So right now I am in /users/jsrvtr, which is my home folder. The home folder is also denoted by that squiggly line. The final command that we're going to look at in this video is the cd command. That stands for change directory, and it lets you move somewhere. So instead of the users/jsrvtr folder, we're going to now move into the price of chair folder. And now if we press pwd, we can see that we've moved from users/jsrvtr to users/jsrvtr/price of chair. And now if we type ls in here, we no longer need price of chair because we are inside the current folder price of chair, so it'll just give us the same thing, which is the files in the current folder. So this is quite a bit to take in. We've looked at how to do a git clone. Remember that it creates a folder called the same as the repository, so in this case price of chair. Then we've looked at ls to list the structure of a folder, pwd to look at what directory we're currently in, and finally cd to change directory. Hope that's all good, and I'll see you in the next video. Hi and welcome back. In this video, let's quickly talk about the different statuses that a file may be when it's in Git. So the first status is the very bottom one, untracked. When you just created your repository and you create a new file, Git doesn't immediately start following the changes to that file. Until you tell Git to start tracking the file, then Git will simply acknowledge the file is there, but not do anything with it. If you tell Git to do something to all the files, it will not do anything to those that are untracked. So Git by default won't start tracking files automatically. And the small description there in untracked is that the file has never been in the repository before, and that is essentially true. When your file has never been in the repo, then Git will tend to ignore it until you tell it otherwise. And the way you tell it otherwise is by making sure that it has been in the repo before. So if a file has been in the repository before, then Git will start tracking changes and following what you do to the file. Notice that doesn't mean that Git will store those changes or push those changes to GitHub for you, but you will be able to tell Git to do something to all the files, and then only those tracked files will be contained amongst those quote-unquote all files. The next stage up is modified, and Git, whenever you make a change or you create a new file, will give this status to a file. This status is kind of independent to tracked or untracked. And then whenever you want to start working with the files, meaning doing a commit and then pushing that commit to GitHub, you need to add the file. So there you would do a git add, and that would move a file from the modified status to the staged status. And what that means is that the file has been added to the staging area. The staging area is nothing more than a status in Git. Notice that it doesn't move your files in your disk anywhere. It simply tells Git, hey, these files are ready to be committed. Once you've got some files in the staging area and you want to commit them, you simply do git commit. And that creates a commit and lets you write a commit message. Now what happens when you do a commit is that those files that you had in the staging area, the files that were staged, are now bundled together. Those changes that you've made to the file are given the commit message you write for the commit, and then they are stored safely inside your Git folder. That way, in the future, when you want to refer back to a set of changes, you'll be able to see the commit message and then link those changes up to the commit message, and you'll be able to easily understand what happened at that point in time. Finally, the last status is pushed, And that happens when you've got one or more commits that you've made locally and you want to put them in the GitHub repository for other people to see or use, or just to store them remotely for security purposes. Once you've got one or more commits, you can do git push, and that will push those commits over to the remote repository. Remember, the remote repository may be in GitHub, but there's also other services like GitLab or Bitbucket that are also available. This is all well and good, but oftentimes we make a mistake, or we do a commit when we didn't want to do a commit, or we staged some files that we didn't want to include in a commit. This is why Git also supports reversing these changes. Let's talk about reversing a pushed commit. These are the most dangerous types of reversals. This is because once you've pushed your changes to the remote repository, other people may have downloaded those changes. And then if you revert the changes, then some code or some files may suddenly disappear from their local workspace when they decide to download the repository again. So this is why reversing a pushed commit is oftentimes not encouraged, and certainly communicate with your team if you are going to be doing that. Nevertheless, the way that you would reverse a commit that has been pushed is by doing git revert and then head and the small circumflex accent. Now what that does is that actually creates a new commit that undoes the changes. So for example, if you commit a new file, then the git revert head with the circumflex accent would make another commit that deletes the file. That way when other people download the repository, they can see that you've actually deleted that file and that is something that has happened in the history. This is unlike the next step down, which is git reset head and the circumflex accent. When you have a commit that you have not pushed, you can choose to delete that commit entirely and pretend that it never happened. That is what git reset head does. It simply gets the latest commits that you've done and undoes it, deletes it, and puts the files back into your staging area as if they had never been committed before. Finally, to move from the staging area to the modified stage, i.e. to unadd the files, you can do git reset and then -- keep. That keeps the changes to the files, i.e. it doesn't delete your work, but it unadds them essentially. It moves them out of the staging area. Notice that that moves all of the files out of the staging area and into the modified stage. Finally, git checkout -- file, notice the spaces there, will remove all the changes that you have made to a file. So it will essentially move it from the modified stage to the tracked stage, deleting all the work that you've done since the last commit. This will not delete the file unless you've created it in the current commit. It will only remove the lines that you've added since the last commit in which this file was included. So I'll be uploading this to the course, and this can be a bit of a cheat sheet, but do notice that this is by no means a comprehensive guide to Git. This is only meant as an overview, and if you have any doubts as to what to do with your Git repository, or you've done something wrong and are unsure of what to do, please ask, because it is easy when you are not sure what you are doing with Git to get some work deleted and essentially lose some of your time by having to recreate that work. So please use this as a guide, keep learning about Git, and if you have any questions, please do ask. Okay, so this is a quick overview to Git, and I'll be seeing you in the next video. Hi and welcome back. It is possible that you got an error in the last video when you were trying to clone the repository, and if you didn't, it is possible that you will get an error in the future when you're trying to push to your repository. And this error is to do with permissions to access the repository. In some instances, it is possible to use your account and your password to interact with GitHub. However, most of the time it is preferable for your computer and GitHub to know that each other have access to downloading and uploading files. And the way we do this, the way that the computer and GitHub know whether access is allowed, is not via the username and password, but rather your computer can store a file which is called an RSA key or an SSH key, and then you can upload that key to GitHub. Then when your computer interacts with GitHub, it sends the key, and GitHub can then verify that the computer is indeed yours, and therefore you should have access to downloading the files. When you are generating a key, it is always going to be a unique key. This means that if somebody else generates a key, they won't be able to access your account because the keys will be different. The way we generate a key using the terminal in Linux or Mac or the PowerShell in Windows is by doing ssh/keygen. When you do that, then it tells you that it's generating a public and private RSA key pair, and it asks you which file to save the key to. I would recommend just pressing enter at this stage and saving it in the default place, which is /users/your account/.ssh/id_RSA. And then just press enter every time after that as well, and that will generate an RSA key that you can use to identify your computer with GitHub. You can optionally, during this process, enter a password for your RSA key, and then whenever you try to interact with GitHub, it will ask you for the password of the key. Normally, I tend to not give these keys a password. However, it is obviously more secure if you do. Remember, however, that these keys are stored in your computer, and that in order for somebody to log into GitHub using your key, they would have to be in your computer, or they would have to otherwise copy your key into their own computer. So it's difficult to do. Giving it a password increases security, but it also is a bit of a hassle since you have to input it every time. So once you've generated your key, then we can proceed and put it into GitHub. So my key, which I'm not going to show you here for security purposes, and your key as well, if you just press enter every time, can be found by using the cat command. This cat command essentially outputs the contents of a file. And the way you would find your key would be by doing cat and then the path that is shown here. So /users/JSRVTR, in my case, /.ssh/IDRSA.pub for the public key. And you can share this public key with the service GitHub, or indeed a few other services that accept SSH keys or RSA keys too. So cat those contents and you will get the output of your RSA key, and you can copy the entirety of that output and paste it in the GitHub appropriate place, which we're going to view now. So copy the contents of that command and then go into your settings, your profile, here in GitHub, edit your profile, select SSH keys and create a new SSH key, put a title of the key that you want, and then paste in the contents of your file. Make sure that when you paste the contents, there are no new lines. There's only ever a continuous string of text, and sometimes it may have a space or two somewhere at the end. But make sure there are no new lines, and sometimes when you're copying the content from the terminal, it kind of divides in weird ways. So make sure there are no new lines in the key you paste. Give it a title, doesn't matter what title you give it, and then just press add SSH key. And now, whenever your computer communicates with GitHub, it will send the public SSH key along, and GitHub will know that your computer has access to your account in GitHub because of the SSH key that is shared between GitHub and your computer. So once you've done that, you'll never have problems again with authorization or logging in. So I'll see you in the next video. Hi and welcome back. In this video, we're going to learn how to make changes using the terminal and how we can then commit and push those changes to GitHub. So one thing to realize is that the repository is hosted on GitHub, and that is publicly accessible, so anybody can see the GitHub repository, and it has some files. And what you've done is you've copied all of those files into your local computer. So now you've got a copy of the repo, of the repository, in your local computer, and GitHub has another copy that is remotely. But those copies are completely independent, and when you make a change in your local copy, it will not be available in the remote copy until you upload it. So the first thing to do is type in git status, and that is going to tell you the current status or the current status of your repository, of your local repository. So what it says is you are on the branch master, and branches are not something that we're going to cover in this course. There is a separate course for that. And it's saying that your branch, which is master branch, is up to date with origin/master. So origin/master is the remote repository, the one in GitHub, and it's saying that your local branch is up to date, so they are both essentially at the same level. There are no changes made. And it also says nothing to commit, working directory clean. Basically, you have not made any changes locally. You haven't changed any files, so there's nothing to do. Git is used to make changes and then upload those changes over to the remote service, in this case GitHub, and Git is telling you that you haven't done anything yet, so there's nothing it can do. So let's change that. Let's make a quick change so that we can actually upload that to GitHub and learn a thing or two about Git. What I'm going to do is I'm going to type vi, and the vi program is a text editor. So typing vi and then, for example, readme.md is going to open the readme.md file with the vi program. And the vi, as I said, is a text editor, so it's going to allow us to modify the readme file. So press enter, and here you can see the contents of the readme, which are available on the GitHub repository page. So this content here is then rendered as this content over here. So let's make a quick change just so GitHub can see that we've made a change. You can say, for example, forked version by, and I'll put my name in. You can put your own name, just to make a quick change and to tell the world that you've done this as well. So forked version by me, and then remember to press escape :WQ to write and quit when you're using Vim. And now you've made the change, so we can ask Git to check, see if we've done anything. So let's type git status again. And now it tells us that we are on the branch master like before. We're still up to date, meaning the remote repository doesn't have anything new for us, but we've got changes that haven't been staged. And this staged word is actually very important in Git. So basically what this is telling us is we've made a change, but we haven't told Git that we are going to want to upload it to the remote repository. Git has 3 levels. It has your working directory, it has the staging area, and finally it has the remote repository. When you commit, you are essentially telling Git, I have made these changes and now they are ready to be pushed over to the remote repository and uploaded. Before you can commit files, you need to add them to the staging area, which is essentially just a small area where you can put files that are going to be then committed. Finally, your working directory is those files that you haven't told Git you want to commit. So right now, if we type git commit, then it tells us that we have not added any changes to commit. So Git doesn't see anything that we want to commit. Before we can commit anything, we have to add it to the staging area. notice how it says changes not staged for commit and tells us the file. We're gonna say git add readme.md, and now if we type git status, it says changes to be committed, and now the readme file is to be committed. So when we now commit, Git will make this file ready for uploading and pushing, essentially. So the way we do that is we say git commit -m, and then we can type a short message. If we do not type -m, then it opens up Vim for us to write our message in. But we're going to type -m and say added authorship in readme file. Make sure to write a reasonably comprehensive and descriptive commit message, so that then when you're going through your commits that you've done in the past, you know what was done in each. Let's do that, and now it tells us that we've made a new commit. It gives the commit a code, and it also tells us that we've changed one file, added 3 new lines, and deleted 1 line. Okay, and now if we press git status, then it tells us nothing to commit, because we haven't made any changes that haven't been committed yet. So all our changes are now ready to be pushed, and it says that our branch is ahead by 1 commit. So there's 1 commit that we've got in our local copy that is not in the remote copy. So let's say git push, and now notice how this window pops up saying, are you sure you want to give Git the access to your confidential information? And I'm going to say always allow. And now that uses that SSH key to upload the stuff, the files, over to GitHub. And notice how the commit that we made, code 86C550A, is now the one that is appearing here as well. Okay, and now when we say git status once more, it tells us that our branch is up to date. When we go over to our forked version of the repo, which we can get over here, let's just go over to it. That was another, I think. There we go. Notice how the latest commit is this 86C550A 2 minutes ago, which is the one we just made. And how the readme file also presents forked version by me. So when you've done all that, you should see this forked version here by yourself, and that should be in your forked repository. So once you've done all that, we are essentially ready to continue using Git and starting to deploy into a server. So this was just a quick overview of what Git can do, but by no means a comprehensive course on Git, but that's something that we can learn in other courses. Okay, I'll see you in the next video. Hi and welcome back. If at any point in time you want to check what commits you've done before, or indeed if you're working with other people and you're all using Git, what commits everyone has made, you can use the git log command. So simply type git log, and that tells you all of the commits that have happened over the past lifetime of the project. So here we're seeing a bunch of commits that I've done on this project, and it tells you the author, as well as the dates and times, and the commit codes as well. And that's especially useful if you want to go back and see the commit messages for each of the commits that you made, and just to make sure that you are still able to identify what happened in the past. And if you're searching for a commit that did a specific thing, you can use git log to search through the commit messages and find the commit that you're looking for. Okay, so this is the end of this introduction to Git, and now we're going to start moving into deploying. So I'll see you in the next video. Hi and welcome back. In this video we're going to be registering for Heroku and understanding what it is. In order to register, simply come to www.heroku.com and press the sign up button. Here you can create your account giving your email, and optionally your company name, and optionally select your primary development language. After that, just create your free account, and that's really everything you've got to do. Now, what is Heroku? Heroku is essentially a place where you can rent servers. Basically, what they give you is a computer, just like the one you're using now to view this video, and you can make that computer publicly viewable so that other people can connect to it. If you run your Flask application in that computer, then other people can connect to it over the internet and access your Flask application. That's essentially what a server is. So what these people are doing is renting out servers. And they rent out many different types of servers. Some are very cheap, some are quite expensive, and they charge on a per hour or per minute basis. However, the way we're going to use Heroku is for free, and they give you one free server to use for an unlimited amount of time. So essentially we'll be using Heroku for our development and testing of our application. In the free tier, when they don't charge you, they turn off your servers for a certain number of hours per day. So it's not ideal when your users access your application and it's offline. Therefore, we're only going to be using Heroku to test our application, making sure that we can deploy it well, and while you are making applications, you can use Heroku to verify that they work well on the internet. But when you want to deploy your application to end users in a production environment that they are going to use all the time, you may not want to use the free tier in Heroku. You can either pay for Heroku, or we can use another service called DigitalOcean. So we're going to learn how to push our code to Heroku, how to deploy it here, just for the learning of it, and so you can use it in your development. And later on in this section, we're going to learn how to deploy to DigitalOcean, which is cheaper and will let you share your code for your end users when your application is finished. So we're going to be learning both. And remember, Heroku has a free tier, so you don't have to pay anything, or you don't have to give them your credit card details or anything. Okay, so once you've signed up, let's move on to the next video. Hi and welcome back. In order to start deploying to Heroku, the first thing we need to do is download the Heroku tool belt, which is a command line utility for using Heroku. This is going to save some time and allow us to do some things in Heroku, like setting up how many servers we are going to be using for our application. So in order to install the Heroku tool belt, simply download it for your appropriate version and simply install it like a normal program. A link to this page will be in the description of the video. Okay, so once you've downloaded and installed the Heroku tool belt, you'll have to do a Heroku login and then enter your Heroku credentials, which is your email and the password you used to sign up for Heroku, inside your terminal. And once you've done that, we are ready to continue and then get started with deploying to Heroku. Okay, I'll see you in the next video. Once you've got the Heroku tool belt set up, it is time to create our application here in Heroku. What to do is go to the top right corner and click on Create a New App. Here you can put the app name, which is optional, and if you don't put one, Heroku will create one for you. Here I'm going to call it Pricing Service, and it is not available, so I'm going to just put School of Code at the end, and that seems to be available, so that's fantastic. If you leave it blank, they'll choose one for you, but remember, this is going to be part of the address of your application once it's deployed, so you probably want to pick something that makes sense. And here is where the app is going to be running. Since I'm in Europe, I'm going to select Europe, but you may want to choose other options. And here in this final set of options, you can add it to a pipeline. And a pipeline is something that we're not going to be getting into in this course, but essentially lets you connect multiple apps together so you can reuse code in between them. And we don't really care about that in this case because our app is a standalone app. So once that's done, press on Create App. And there you are greeted with the app screen. The next thing to do is to connect the app to the GitHub repository that we created earlier. So what I'm going to do is press the button and then connect to GitHub down here. There, my GitHub is already connected, so you can put that in there and then select here price. I'm going to search this one. So I'm going to connect to that. Finally, we can enable automatic deploys from GitHub. So what this means is that every push to the branch that we specify here, so whenever we push our code to GitHub, then it is going to get deployed into Heroku, and the code is automatically going to be copied over to the Heroku server that we are going to be getting for free, and it's going to be running just like that. So we should enable automatic deploys for the master branch, and you do not want to check this checkbox here. Wait for CI to pass before deploy, because what that'll do is it'll assume that you've got some tests running, which we do not have in this project, but we will in the future. So for now, let's not check that and just enable automatic deploys. So now automatic deploys from master are enabled, and the master branch is one of many branches that we can have in our GitHub repository, so in our Git repository, and the master branch tends to be the main branch of our repository. As I mentioned earlier, this is not a course about Git, so if you want to learn more about that, there are other courses that are available for that. For now, we're only going to be using the master branch in this project, so assigning automatic deploys from master seems like a good thing. You do not want to enable review apps, as we're not going to be working in a team, so we're not really bothered about that. And then we can finally do a manual deploy. Right now, our application is not configured to be deployed to Heroku, so if we do a manual deploy, it will not work. So first, let's continue and set up the application to be deployed to Heroku, and once we've done that, we can then proceed and actually do the deployment. Okay, so I'll see you in the next video. Hi and welcome back. In this video, we're going to be setting up our app to run in Heroku. And the first thing we have to do is to make sure that our application has all the properties that it needs, all the configuration properties that it needs in order to run. One of the first configuration properties that we need to modify is in the source.config.py file. And these are the admins frozen set. And here notice that I've already got, as in a previous video, my email address there as the main and only administrator. That's all fine. If your email is in your GitHub repository, remember it is public for people to see. In my case, I am not particularly bothered about this because my email is in many other places in the internet. But if you do not want your email to be available, then you cannot put it in your GitHub repository. And indeed, you cannot put it in Git. In this case, I don't care about this, but we're still going to understand how we can not put the email there, but still be able to access it from our application. Instead of using the config for that example, we're going to be using something that does matter a bit more, which is the models.alerts.constants file. Here, we've got the URL, API key, and the from for the Mailgun API. Notice how these values are supposed to be hard-coded here in these variables. However, if we put the API keys here, and then we push this code to GitHub, then it is publicly viewable, and anybody could use our API key to send emails. Mailgun limits on the number of emails you can send per month, so it is not a good thing if other people are using our API as well. So what we want to do is hide this from other people, and the only way to do that is to not include it in our GitHub repository. There is something that we can use instead, which is called an environment variable. An environment variable is something that is unique to each computer, so you can set an environment variable in your computer, and then your application can access those environment variables and get the value from them. So, for example, in your laptop or your computer, you could set an environment variable called API key, put the value of the API key for Mailgun inside that environment variable, and then your application can access that variable and get the value from it. Naturally, it's not too great for development because you really don't have a reason to hide it while you are developing. However, when you are going to push your code to GitHub, it is necessary to avoid putting sensitive information in GitHub. Fortunately, Heroku lets us define environment variables as well, and we can use them from inside our application. So what we're going to do here is assume that we have already set the environment variables, and we are going to, instead of hard coding the value of the environment variable of the API keys and URL and from, we're going to get them from an environment variable. In the next video, we'll be setting up the environment variables in Heroku. The way to do this is to say os dot, and we'll have to import os. That stands for operating system. It's a package in Python that lets us interact with the operating system. os.environ.get, and then just say mailgun URL. So the environment variable is going to be called mailgun_URL. And what this is going to do is it's going to get the value of that environment variable and put it inside our URL variable. Then we're going to copy that, paste it in there, copy that, paste it in there as well, and rename that mailgun API key and mailgun from. So what this is going to do is we're going to now need to define these three environment variables inside Heroku, and then when this file opens, it's going to load the values from those environment variables into these three variables here, which is what our application is using. And what that means is that now these environment variables are set in our Heroku account and not publicly available for anyone else to see. Naturally, if you want to also hide your email, the only thing you have to do is change this config file to be in the same format, os.environ.get, and then the name of your environment variable, which you can define to be your email. So you can have 4 environment variables instead of 3 if you want to hide your email too. So that's how we get the values from environment variables, and we're going to work on how to set those in the very next video in Heroku. I'll see you there. In this video, we're back here at Heroku, and we're going to be defining our environment variables. In order to get your environment variable values, you'll need to go into your Mailgun account and find out the API key, the URL, and the from email that your Mailgun account is using. And then we'll just go into our app in Heroku, press settings, and here we can reveal config vars, and it will tell us that there are no config vars for this app yet. And what we'll do here is simply say mailgun URL, and then set the value here, mailgun.org, blah, blah, blah. So this is going to be unique to you. And then once that's done, just press add, and then add the other ones, mailgun_API key, and add your API key there, and then finally the from as well. Naturally, for security purposes, I won't show you exactly my values, but you get the general idea. Just copy the value that Mailgun gives you and put it in each of these value boxes, and remember to press the add button at the end. Once you've done that and you've got your 3 or 4 config variables if you want to also hide your email, then we are ready to continue setting up our app for deployment to Heroku. So I'll see you in the next video. Hi and welcome back. In this video, we're going to continue setting our app up to work with Heroku. And Heroku needs a couple of things to be able to serve our app and make sure our users can use it. One of the first things that we need is actually something called the wrapping server. Now, Flask, when we run the Flask application, as we've done throughout the course, that creates a local server that we can navigate to in our browser, and that gives us our Flask application. And all that is fine, but Flask is actually not the most efficient of servers. So there's actually a different server that we can use instead of the one that Flask gives us. Basically, what this server will do is it will load up our app and it will serve the endpoints for us just as if it were Flask, only it's slightly more efficient. So what we want to do is go into our project, not inside our source folder, and we're going to create a couple of files. The first one is called runtime.txt, and here we are going to specify what Python version we are using. And the Python version we want to use in Heroku is Python 3.5.1. And now this tells Heroku that the Python version we want to use is Python 3.5.1, which is the latest version as of today. And that's everything this file needs. And the other file that we want to create is called procfile, without a line ending or anything at the end in terms of a suffix. Okay, so once we've done that, we simply have to tell Heroku the name of the sort of service we're running, and we're going to get to exactly what that is in the next video. And then we have to tell it what command to run. So here we'll say we want to use not the Flask server, but we want to use the wrapping server that we are going to install in a moment. And that wrapping server is called UWSGI. And UWSGI is going to run, and it also needs a config file for UWSGI, which tells it how to run, and this is going to be uwsgi.ini. So this is going to be the config file, and that is the program that is running. Web is the name of essentially the server that is going to be running our application. Next up, we need to get UWSGI here in the requirements.txt. And if you go into your app and try to install UWSGI, it may tell you that it cannot do that. In my case, I've got it installed, so it's not prompting me to install it. But if you don't have it installed and it asks you, it may fail because UWSGI requires a C compiler to be installed. But that's fine. It will work in Heroku even if it fails in your computer. Okay. And the last thing we need is the uwsgi.ini file. So let's create that and go and put the content in it. So the uwsgi.ini file requires a heading, which is uwsgi, and this tells the program that is loading the config file that the following lines are related to uwsgi and not any other process. Seems a bit redundant, but nevertheless is required. Then we need to give it a HTTP socket. Sorry, like that. And what this says is load up the port, which is going to be another environment variable, and use that port as our HTTP socket. And this will normally be port 80, as that's the default port for running web applications. Then say master is true, die on term is true, and what that simply does is it says use a master process to control other processes, and then die on term, if the process gets stuck, make sure to terminate it and restart the process. Then we say module and src.app :app. That says load up the file that is inside the source folder, and then app.py, and get the object app from inside it. So what that'll do is it'll load up the Flask app that we've created and use that as the main module. And finally, memory-report is true, and that simply generates a memory report for UWSGI that we can optionally view later on if something goes wrong. We'll most likely not need it. Okay, so once you've got that, we are pretty much ready to continue and start deploying our application. The next thing you have to do before continuing, however, is make sure that you add and commit these files to your forked version of the Git repo. And after that, make sure to push it, and the deployment will start automatically, but it may not work just yet. In the next video, we're going to look at exactly how to make that work and how to view the deployment status as it happens in case we encounter any errors. Okay, so let's do this. commit and add the files, and I'll see you in the next video. Hi and welcome back, and in this video we're just going to be adding the files and committing them and pushing them to our repo. So what to do is type git status to check the status of your files. Notice that we've created 3 files, proc file, runtime.txt, and uwsgi.ini, and then it tells us that we've added some content to them, and we've modified the readme.md as well, and I've done that to try something out, so we're going to have to remove that. And then we've got the requirements.txt that now has uwsgi as well, and the constants that are now getting the environment variable values. So first of all, let's remove the readme.md changes that are not relevant to what this video is about. And here it tells you how you can discard changes. So we're simply going to do git checkout -- readme.md. And now typing git status again shows us that that has been removed. The next thing we'll do is git commit -am, and that is going to include all of these files that have already been added by PyCharm, and let us write a short message. Remember, if these files are not showing as like having been added already, you will need to do git add and add them. Once you do that, they will show up as like that only. Anyway, so git commit am and then write adding required Heroku files and reading from environment vars instead of hard-coded API values. Okay, let's type git status again. Everything is now clear. We're ready to push. So we'll just do git push, and that will send our changes over to the GitHub repository. This will start a deployment in Heroku, but as I said, it won't work just yet because we haven't defined how many servers our application is going to use. So let's do that in the next video. In this video, we're just going to be setting up the Heroku app by telling Heroku how many servers we want to use in that app. We want to use only 1 because that's the limit when we are not paying for Heroku. So if you're using the free tier, you'll always want to use just 1. What to do is type Heroku login, and this will prompt you for your Heroku credentials. Remember, this will only work if you've got the Heroku tool belt installed, as we did in a previous video. So here I'm going to just put my email and password in. So I'll do that, and then I'll get back to you. Okay, so we've put the email and password in, and now we're logged in. What we want to do is make sure that we scale the app and tell it how many servers we want to use. So the command for that is Heroku ps-scale, ps:\scale, and then web, which is the name of our server as we used in our proc file, equals 1. And now this will give us a short error after it installs the requirements because it says that no app was specified. So we need to run this command from an app folder, which we are not doing, or specify which app to use with --app is the app. So let's press the up arrow and then say --app is pricing-service-school of code, which is the one I'm using in Heroku. And now it's saying that it's scaling the dynos, and that's just Heroku's fancy term for servers. And then it says done, and now running web, which is the process, at 1 dyno, which is free. So now that we are ready, we can go to Heroku and see if the app will run. I'll see you in the next video. Hi and welcome back. In this video, we're going to be deploying our app to Heroku, and we're going to be finding out that the app doesn't quite work because of one final thing that is missing. However, the deployment will work. The way to do the deployment is, although it happens automatically when you push to master, it is not as easy to view what has happened during the deploy. So what we're going to do is go to our app, go into the deploy tab, and then scroll down to the very bottom and press deploy branch. This is a manual deploy, And then when we start doing that, it shows us a build log. So it says using buildpack Heroku Python. It tells us that a Python app was detected. Then it installs the requirements.txt file inside Heroku, which is then going to install all the things that are required, like UWSGI, PyMongo, Beautiful Soup, etc. Then it's going to discover process types, and then it's going to essentially compress, and I don't think we can get this back. So it's essentially going to compress and send the code over to Heroku, and it's going to run UWSGI, which is then going to run our app. When we press view, we will get redirected to our application, and we will get an internal server error. Now this means that our app is broken. It failed to do something. And maybe you guys haven't realized, but when we were running the app in our browser, in our local computer, as not in Heroku, we needed to have MongoDB running. And when it's running in Heroku, it cannot access our computer's MongoDB instance. So we cannot really use our local MongoDB, which means we need to be running MongoDB somewhere else where Heroku can access it. And fortunately, Heroku provides some free MongoDB hosting as well. So in the next video, we're going to be adding that add-on, which will allow our app to use MongoDB. So I'll see you in the next video. Hi and welcome back. In this video, we're going to be setting up MongoDB to